So we've skipped 6.2. Do it if you want to for fun, but we're moving on to 6.3. So today is just 6.3 part 1, which is that we are going to start looking at trigonometric functions of any angle. So in 6.1, we looked at trigonometric functions of acute angles, and now we're going to be looking at any angle. So to be able to do that, we have to move into this Cartesian system, or the Cartesian plane, or the coordinate system. Okay, we're going to start moving into, X and Y, and moving out of quadrant 1 and into all the other quadrants as well. So first things first is that when you are reading angles in standard position, it means that you're reading an angle from the positive x-axis being the initial side of the angle, and then you're going to be reading the angle to a terminal side. So it's going to be the angle made between the initial side, which is the positive x-axis, and wherever the terminal side would be. There is this point here, which is the vertex, which is 0, 0, is that the angle is always going to open from that point. Now, when reading angles, you are going to read one of two ways. If you read in a positive rotation, which means counterclockwise, it means that you are going to be reading the angle as positive. So in other words, if you start here, now I'm just going to remind you of these words. So quadrant 1 is top right because it's where x is positive and y is positive. And then we go counterclockwise, right? Quadrant 2, quadrant 3, quadrant 4, and we go around the clock. Okay, so if we're looking at this one, this is an angle in quadrant 2. So if we read it from the initial arm in a counterclockwise direction, this is going to be read as a positive direction, or a positive angle. If we have an angle, it doesn't matter that this is in quadrant 3, but if we have our same initial side here, but instead of reading in a counterclockwise direction, we read in a clockwise direction, we're going to read it as a negative rotation. So in other words, if you're reading counterclockwise, this is 0 degrees, and then it opens up to 90, opens up to 180, opens up to 270, and then around to 360. If you read in a clockwise direction, this is still 0, but you'd go negative 90, negative 180, negative 270, and then all around to negative 360 degrees. Okay, so what does that mean? Now, I already kind of went over this, right? So if you're reading in a positive direction, this is 0 degrees up to 90 degrees. Whereas if you were to read this in a clockwise direction, you'd be going negative 90, negative 180, negative 270 degrees. If you have a straight line, right, so this is a supplementary, it's 180 degrees in a positive direction, but it would also be negative 180 degrees in a clockwise direction. Same thing here, if you had this angle, your terminal arm or side being straight down, right? If you read in a counterclockwise direction or a positive rotation, it would be 270 degrees. And if you read in a clockwise direction, it would just be negative 90 degrees. One full rotation, again, if you went counterclockwise, it would be positive 360 degrees. If we were to go clockwise, it would be negative 360 degrees. Okay, so the next thing we're going to do is just practice looking at where angles will be. So 35 degrees, we want to figure out what quadrant the terminal side lies in, and then I want you to sketch the angle in standard position. Standard position meaning that we are going to always make every single one of these have the initial side be the x-axis. Okay, so if I was to graph 35 degrees, I know that it is between 0 degrees and 90 degrees. And it's less than halfway. So halfway would be 45 degrees, so it would be a little bit less than halfway. We would draw our terminal side, and then we'd put the 35 degrees in here. All right, 210. Same thing. We want to look at what quadrant it's going to lie in and then sketch the angle in standard position. So I'm going to go, okay, it's a positive angle. So this would be 0 to 90, this would be 90 to 180, and this would be 180 to 270. So if I was going to sketch this angle, I can see that 210 is between 180 and 270. Where exactly? Well, if you can get the habit of thinking where it is in relation to 180, it's going to help you in the future. So if I think of 210 degrees being here, right? So it's in the third quadrant, and the angle is that it's 30 degrees past 180. Sorry, I forgot this one. So this one was in quadrant 1, this one is in quadrant 3. Okay, these two angles are negative rotations, but I want you to do the same thing. Think about, if you're reading it, which direction are you reading, and what quadrant will it lie in? So pause the video. Okay, so for me, I still know that this is 0 degrees. I now know this is negative 90 degrees. So negative 40 is almost halfway between 0 and negative 90. So I would go like this. I'd say negative 40 degrees, and this is in quadrant 4. Negative 120, I would do the same thing. So this is negative 90. This is negative 180. So I know that negative 120 is between negative 90 and negative 180, which tells me this is going to be in quadrant 3. But where exactly? Well, what I would love it if you could start doing is that you're not quite at 180. In fact, how far away are you from 180? Well, you are 60 degrees away from 180, or negative 120 degrees from your initial side. Right? Some people would say, oh, but you're 30 degrees past negative 90. And I'm like, that's cool. But going forwards, we're always going to be making triangles with the x-axis. So if you can think 60 degrees away from 180, then that's great. Okay. Next thing. The next thing is that I know in class especially, people were asking like, well, what should I call them? You know, if you look back up here, this terminal arm could be 90 degrees. It could be negative 270 degrees. And the answer is either. This angle here, whether you call it 90 or negative 270, it's still located in the same place. These two angles share the terminal arm, and so we call them coterminal angles. So coterminal is when two or more angles have the same terminal side. In other words, it's just giving the angle a different name. There's a couple ways of doing this. So for example, this angle here, reading from the initial side, could be 60 degrees to the terminal arm. Or what if I said, hey, I'm going to do a full rotation before I get there? So I went 360 and then another 60, and I got to 420 degrees. Those two angles are coterminal. Well, what about these two? What if I said, hey, you know what? If I go counterclockwise, this is 330 degrees. Or I could say that 30 degrees or 330 degrees is 30 degrees away from the x-axis. So if I went in a clockwise direction, it'd be negative 30. Or I could say, hey, you know what? This is 330. If I take away a rotation, instead of adding 360, I can subtract 360, and I get negative 30 degrees. In fact, coterminal angles are always one of the angles plus or minus 360 degrees. So for example, here I could do 135 minus 360, and I would get negative 225. Or I could do negative 225 plus 360, and I could get to 135 degrees. So to find coterminal angles, you just add and subtract multiples of 360 degrees. So for example, if you had 50, you could add 360 or you could subtract 360. So here we go, let's practice. If I wanted to find two positive angles and two negative angles that are coterminal with negative 7, I could do negative 7 plus 360 degrees, which if I do that, I'm always afraid to make a mistake. I know it's 353 degrees, right? So you're just plugging into your calculator, negative 7 plus 360, and you get 353 degrees. If I wanted to find another positive angle, I could add another 360 onto this, or negative 7, I could have added 2 times 360. I could have done 2 full rotations. So either add another 360 onto the answer you have, or add to 720, but you're going to get 713 degrees. So 713 degrees is 2 ways around, and then the 7 taken away. Okay, so if we wanted to find negative coterminal angles, instead of adding 360, we would subtract 360. So one of my angles would be negative 367 degrees, or I could have subtracted 2 times 360 degrees, and I would get negative 7 minus 2 times 360, negative 727 degrees. So there are 2 positive coterminal angles and 2 negative coterminal angles. Just in case you're still not quite there, let me just show you this one. So if we had 50 degrees, when you're finding coterminal angles, so this is 50. To find a coterminal angle, the only difference is that instead of going once around, like up to the terminal arm, we go once around and back up. So this would be your 410. Or the other way is that instead of reading clockwise or counterclockwise, we read clockwise, And you'll notice that those two angles here, the positive and the negative coterminal, will always add to 360. So 50 and 310 make 360, but one of them's a negative rotation and one of them's a positive rotation. So just to make sure my notes are complete. Okay, next thing before we take our first break is classification of angles. So these are some words that you should be familiar with. The first one's acute. We talked about this yesterday. They're so cute, right? They're less than 90 degrees. So acute angles are always angles less than 90. A right angle is an angle that measures exactly 90, and an obtuse angle is an angle greater than 90 but less than 180, right? So it's going to be less than 180 but greater than 90. Okay, now that you're comfortable with language, the next skill is to find complementary and supplementary angles. So complementary angles are two acute angles whose sum is 90 degrees. In other words, 10 and 80 add together to give you 90, so they are complementary. Supplementary is two angles that instead of adding to 90, they add to 180, and they're not acute. One of them might be, but they can't both be. So for example, 45 and 135, if you add those together, you get 180 degrees. On a test, it'll say find a complementary angle to blah, or find a supplementary angle to blah. So how do you remember the difference between the two? Well, supplementary has the word supple in it. So I always think of someone who's really supple as being able to do the splits. So that's how I remember that supplementary angles add to 180 versus complementary angles add up to 90. Complementary is just being right? It's a good thing to be complementary, so that makes a right angle, which is 90 degrees. That's my other part. Okay, so if I asked you to find the complement and the supplement of 71.46 degrees, the first thing we're going to do is find the complement. So complementary angles add up to what? 90 degrees. So to find a complementary angle, you're just going to subtract 71.46 from 90, and you get 90 minus 71.46, and you get 18.54 degrees. Then the next thing is to find a supplementary angle. So to find the supplement, they add to 180. So you would go 180 minus 71.46, which is 108.54 degrees. Make sure you are including your degree symbols. I know I keep dropping them. I always make sure my final answer has it though. So sometimes I'll leave the angle, like the degree symbol, out when I'm working, but I will always make sure that my final answer has the degree symbol, because we are going to be moving on to radians, and it's going to be very important to distinguish if this is a degree answer or a radian answer. And radian answers don't have the degree symbol. That's the biggest difference. All right, good luck with part 1.